Hope you guys like the new setup. I see now that I'm probably gonna have to do something with the colors, with the color scheme for the messages. But thank you all for joining. And with that, let's kind of just get into this real quick. So, Calvin, I know you said this was probably gonna be a little too easy for me, but I promise I'm gonna try to get through it as quick as possible. Like I said, I eventually want to get to the more harder stuff, but I definitely also want to have, go through the process the right way. So let's do this. I'm gonna try to change the colors on the font. So let's keep it in. Let's keep it in the family of what else I got going on. And where'd it go? Okay. And then I'm gonna say the visual settings, font settings, chatter. All right, cool. All right, so like I said, so once again, if you haven't done so already, please remember to like, follow, subscribe wherever you're watching. And if you want to support, you can also go here to buy me a coffee and check me out over there. Like I said, I'm working on putting up some exclusive stuff up there. I'll probably have any content that I'm creating or that I'm putting out putting out and selling. It'll be on there for the followers first or the supporters first, and it'll probably be there at a discounted rate. So, make sure you check me out over there. As always, you can follow me here on Twitch and on YouTube. All right, cool. Now, let's just go through here. So the aim of this room is to provide a beginner's introduction to basic principles of networking. Networking is a massive topic, so this really will just be a brief overview. However, it will hopefully give you some foundational knowledge of the topic. So, all right, we're just going to try to burn through this. If you guys have any questions, you know what to do. All right, so the OSI model, the Open Systems Interconnection Model, is a standard model which we use to demonstrate the theory behind computer networking. In practice, it's actually the more compact TCP/IP model that real-world networking is based off of. However, the OSI model in many ways is easier to get an initial understanding from. The OSI model consists of several layers. So the OSI model, if you look, it goes backwards. So from top to bottom is actually 7 to 1. So you have your application layer at 7, presentation 6, session layer at 5, transport at 4, network layer at 3, data link layer at 2, physical layer at 1. So physical is basically like all your hard, like your actual physical devices. Hey, what's going on, Dave? How you doing? So people usually have little mnemonics or something that you can use. Well, there are many mnemonics floating around to help you learn the layers of OSI model. Search around until you find the one you like. I personally favor anxious, pale, Shakespeare treated nervous drunks patiently. So that's one way to do it. I go from top to bottom and I say all people seem to need data processing. Oh no, I appreciate it. I appreciate you stopping by. Let me see if I can move this box over so people can see the whole chat. Move over a little bit more. There we go. So basically, Dave, you're just tuning in. This is a new setup. So the other new setup got messed up. So I'm working on a new one, and it's basically like you see a work in progress. Please do not throw salami pizza away. That's mine. That's how I got through my CCNA. Yeah, everybody has their own. Everybody has their own new. Actually, that's a good thing to do. Anybody who has any mnemonics or analogies they have for the OSI model, put them in the chat. So like I said, so I have all people seem to need data processing. This one says anxious, pale, Shakespeare treated nervous drunks patiently. Noob got please do not throw salami pizza away. Thanks, Dave. All right, so cool. So let's just break down each of these. So again, going from top to bottom, it goes 7, 6, 5, 4, 3, 2, 1. So layer 7 being the application layer. The application layer is essentially provides the networking options to programs running on a computer. So it works almost exclusively with applications, providing an interface for them to transmit data. When data is given to the application layer, it's passed down to the presentation layer. So this is basically the application on the machine. Now it goes down to presentation. The presentation layer receives the data from the application layer. This data tends to be in the format of the application understands, but it's not necessarily in a standardized format that could be understood by the application layer. In the receiving computer, the presentation layer translates the data into a standardized format, as well as handling any encryption, compression, or any other transformations to the data. With this complete, the data is passed down to the session layer, which now we're in session layer 5. When the session layer receives a correctly formatted data from the presentation layer, it looks to see if it can set up a connection with the other computer across the network. If it can't, then it sends back an error and the process goes no further. If a session can be established, then it's the job of the session layer to maintain it, as well as cooperate with the session layer of the remote computer in order to synchronize communications. The session layer is particularly important as the session that it creates is unique to the communication in question. This is what allows you to make multiple requests to different endpoints simultaneously without all the data getting mixed up. Think about opening 2 tabs on a web browser at the same time. When the session layer has successfully logged a connection between the host and remote computer, the data is passed down to layer 4, which is the transport layer. Transport layer is, Transport layer is a very interesting layer that serves numerous important functions. Its first purpose is to choose the protocol over which the data is to be transmitted. The 2 most common protocols are TCP, which is Transmission Control Protocol, and UDP, User Datagram Protocol. With TCP, the transmission is connection based, which means a connection between the computers is established and maintained for the duration of the request. This allows for a reliable transmission, as the connection can be used to ensure all the packets all get to the right place. The TCP connection allows the 2 computers to remain in constant communication to ensure that the data is sent and at an acceptable speed, and that any data loss is resent. With UDP, the opposite is true. Packets of data are essentially thrown at a receiving computer. If it can't keep up, then that's its problem. This is why a video transmission over something like Skype can be pixelated if the connection is bad. What this means is that TCP would usually be chosen for situations where accuracy is favored over speed. For example, file transfers, uploading a web page. And UDP would be used in situations where speed is more important, like video streaming. So with TCP, the TCP is the TCP handshake. So you have the SYN, the SYNAC, and then the ACK, where the SYN, it sends it out, and so it sends out the request. The SYNAC acknowledges that it got the request, and then the ACK is where it basically makes a connection back. Where UDP is literally just like throwing it, and if it makes its target, that's great. So like I said, things like video streaming or like Wi-Fi calling or anything like that, any type of communication, like that's why when things get laggy or choppy, that's because it's using UDP, and it's just kind of throwing the packets at it, and if it's catching it, then cool, and it's maintaining the connection, then fine. If not, then the connection just drops, and then it picks up wherever it can. UDP is used with port 53 DNS. Yep. Yeah, okay. Where are we? Okay. Layer 3. The network layer is responsible for locating the destination of your request. For example, the internet is a huge network. When you want to request information from a web page, it's the network layer that takes the IP address for the page and figures out the best route to take. At this stage, we're working with what is referred to as a logical addressing, i.e. IP addressing, which are still software controlled. Logical addresses are used to provide order to networks, categorizing them and allowing us to properly sort them. Currently, the most common form of a logical addressing is the IPv4 format. Don't tell Tyrone Wilson that, who loves IPv6, which you'll likely be familiar with. So, all right. Layer 2, data link layer. Data link layer focuses on the physical addressing. So this is your MAC addressing. It receives a packet from the layer, From the network layer that includes the IP address for the remote computer and adds the physical MAC address of the receiving endpoint. Inside every network enabled computer is a NIC or network interface card, which comes with a unique MAC address, media access control address, to identify it. MAC addresses are set by the manufacturer and literally burnt into the card. They can't be changed, although they can be spoofed. When the information is sent across a network, it's actually the physical address that is used to identify where exactly to send the information. Additionally, it's also the job of the data link layer to present the data in a format suitable for transmission. The data link layer also serves an important function when it receives data, as it checks the received information. Checks the received information to make sure that it hasn't been corrupted during transmission, which could well happen when the data is transmitted by a layer 1, the physical layer. Physical layer is exactly what it sounds like. Physical layer is right down to the hardware of the computer. This is where the electrical pulses that make up the data transfer over a network are sent and received. It's the job of the physical layer to convert the binary data of the transmission into signals and transmit them across the network, as well as receiving incoming signals and converting them back into binary data. All right, cool. So, which layer would choose to send data over TCP or UDP? All right, so how are we doing in the chat? Let's do this. If you guys don't know by now, like I said, I'm streaming on both YouTube and Twitch. And I'm actually messing around with this Stream Deck that my wife got me for Christmas. So I'm checking out the buttons and stuff. It's a pretty slick. All right, so let me see who here. That's not good. Okay. All right. So anyway. All right. So back to what we were doing. Which layer checks receive packets to make sure they haven't been corrupted? So that was 2. Which layer would data be formatted in preparation for transmission? So the transmission layer or transport layer was 4, so that would probably be 5. Which layer transmits and receives data? Oh, that was wrong? Which layer would data be formatted in preparation for transmission? How did I get that wrong? What did I say? No, I put 5. Standardized receiving computer translates the data standardized format. What the hell did I do? Tentative format understands session layer. Session layer particular importance communication transport. MAC address additionally. Right, but the application. Let me read the question again. Which layer would be formatted in preparation for transmission? Okay, wait a minute. I guess we just gonna go through the whole. There we go. Oh, okay. Which layer transmits and receives data? Let me make sure I read the question properly. All right. Where the hell are we? Okay. Which layer encrypts, compresses, or otherwise transforms the initial data and gives it the standardized format? Now, we're going to go through this again because I seem to have drawn a blank. Presentation layer, okay, when the session layer receives a correctly formatted connection, it can be an error. Transfer layer, very interesting later. Reliable transmission. So what? I can't see. Are y'all saying? Okay. I don't know what's going on with this Streamlabs thing. All right. All right. So let's see here. We're saying it is encrypted, standardized. So that would be 6. All right. Okay. What layer tracks communication between the host and receiving computer? That would be 5 because that's the session layer. Session layer receives correctly formatted from the presentation layer. So we're going to say 5. All right. Which layer accepts communication requests from applications? I need to get one of the receives communications from the computer. Communication from applications. So that would also be no. That would be 7, no? Okay. All right, I'm feeling better about myself now. Which layer handles logical addressing? That would be 3. Okay. When sending data over TCP, what would you call the bite-sized pieces of data? So let's go back up to TCP. That would be segments. All right. Which layer would the FTP protocol communicate with? That would be 7. Okay. Which transport layer protocol would be best suited to do live video? And we talked about that. That's UDP. Okay. All right. How are we doing over here? All right. Sorry about that, everybody. I don't know what that was about. All right. We still here? We still good? Chad, what's going on? All right, as the data is passed down each layer of the model, more information containing details specific to the layer in question. I blame it on it's late in the day. My quiz hours are from 9 to 5. um, Start a transmission. As example, the header added by the network layer would include things like the source and destination IP address, and the header added by the transport layer would include, amongst other things, information specific to the protocol being used. The data link layer also adds a piece at the end of the transmission, which is used to verify that the data has not been corrupted on transmission. This also has the added bonus of increased security, as the data can't be intercepted or tampered with without breaking the trailer. This whole process is referred to as encapsulation, the process by which data can be sent from one computer to another. And then we have the different stages. Application layer is added. Stage 1, presentation, session, transport, network, data link, and then encapsulated data is sent across the network. Notice that the encapsulated data is given a different name at different steps of the process. In layers 7, 6, and 5, the data is simply referred to as data. In the transport layer, the encapsulated data is referred to as a segment or a datagram. Depending on the TCP or UDP has been selected as a transmission protocol. At the network layer, the data is referred to as a packet. When the packet gets passed down to the data link layer, it becomes a frame, and by the time it's transmitted across a network, is broken down into bits. When the message is received by the second computer, it reverses the process, starting at the physical layer and working up until it reaches the application layer, stripping off added information as it goes. This is referred to as de-encapsulation. As such, you can think of the layers of the OSI model as existing inside every computer with network capabilities. Whilst it's not actually as clear cut in practice, computers all follow the same process of encapsulation to send data and de-encapsulation upon receiving it. The process of encapsulation and de-encapsulation are very important, not least because of their practical use, but also because they give a standardized method for sending data. This means that all transmissions will consistently follow the same methodology, allowing any network-enabled device to send a request to any other reachable device and be sure that it will be understood, regardless of whether they are from the same manufacturer, use the same operating system, or any other factors. All right, let me just check my stuff real quick. Okay, what are we doing in the chat? Okay, same old stuff. Yeah, I'm just trying to get back to the streaming stuff before Thursday's show. How would we refer to data at layer 2 of the encapsulation process with the OSI model? So layer 2 is up here, so that would be frames. Let's make sure we spell it right. Okay. How would you refer to the data at layer 4 encapsulation process with OSI model if the UDP protocol has been selected? So that would be a datagram. Okay. What process would a computer perform on a received message? Received message is de-encapsulation. So that is DE. Okay. Which is the only layer of the OSI model to add a trailer during encapsulation. So that is the data link. Does encapsulation provide an extra layer of security? Aye. Okay, cool. All right, so where are we now? All right, TCP/IP model. Okay, TCP/IP model in many ways is very similar to the OSI model. It's a few years older and serves as the basis for real-world networking. The TCP/IP model consists of 4 layers: the application, transport, internet, and network interface. Between them, these cover the same range of functions as the 7 layers of the OSI model. So you see, TCP/IP has application, transport, internet, and network interface. Some recent sources split the TCP/IP model into 5 layers, breaking network interface into data link and physical layers, as with the OSI model. This is accepted and well known, however, is not officially defined, unlike the original 4 layers, which are defined in RFC 1122. It's up to you which version you use, both are generally considered valid. You would be justified in asking why we bother with the OSI model if it's not actually used for anything in the real world. The answer to that question is quite simply the OSI model, due to being less condensed and more rigid than the TCP/IP model, tends to be easier for learning the initial theory of networking. So the two models match up something like this. So for application, presentation, and session in OSI, that would be considered the TCP/IP. Transport is the same. And then network would be considered internet, and then data link and physical would be considered the network interface. The process of encapsulation and de-encapsulation work in exactly the same way with the TCP/IP model as they do with the OSI model. Each layer of the TCP/IP model is a header. A header is added during encapsulation and removed during de-encapsulation. Now let's get down to the practical side of things. A layered model is great as a visual aid, and it shows us the general process of how data can be encapsulated and sent across a network. But how does it exactly happen? When we talk about TCP/IP, it's all well and good to think about a table with 4 layers in it. Excuse me. But we're actually talking about a suite of protocols, a set of rules that define how an action is to be carried out. TCP/IP takes its name from the two most important of these: the transmission control protocol, which we touched upon earlier, that controls the flow of data between two endpoints, and the internet protocol, which controls how packets are addressed and sent. There are many more protocols that make up TCP/IP suite. We'll cover them in later tasks. For now, let's talk about TCP. Still good? You guys still good out there? As mentioned earlier, TCP is connection based. In other words, before you send any data via TCP, you must first form a stable connection between the two computers. The process of forming this connection is called a three-way handshake. So this is what I was talking about before with the SYN, the SYN-ACK, and the ACK. When you attempt to make a connection, your computer first sends a special request to the remote server indicating that it wants to initialize a connection. This request contains something called a SYN, short for synchronized bit. When it essentially makes the first contact and starting the connection process, the server will then respond with the packet containing the SYN bit, as well as another acknowledgement bit called the ACK. Finally, your computer will send a packet that contains the ACK bit by itself, confirming that the connection has been set up successfully. With the three-way handshake successfully completed, data can reliably be transmitted between two computers. Any data that is lost or corrupted on transmission is resent, thus leading to a connection which appears to be lossless. So here's your client, here's your server. Okay, then you have your SYN that from the client to server responds with the SYN ACK, and then the client sends back the ACK. Okay, we're not going to go into it step by step. Okay, it's important to understand why the TCP/IP and the OSI models were originally created. To begin with, there is no standardization. Different manufacturers follow their own methodologies, and consequently, systems made by different manufacturers were completely incompatible when it came to networking. The TCP/IP model was introduced by the American DoD in 1982 to provide a standard, something for all of the different manufacturers to follow. This sorted out the inconsistency problem. Later, the OSI model was also introduced by the International Organization for Standardization, ISO. However, it's mainly used as a more comprehensive guide for learning, as the TCP/IP model is still the standard upon which modern networking is based. Okay, so which model was first, TCP or OSI? So it just said there's TCP/IP. Okay, which layer of the TCP/IP model covers the functionality of the transport layer? That falls under the transport. Okay, which layer of the TCP model covers the functionality of the session layer in the OSI model? That was application. Network interface of the TCP/IP model covers the functionality of two layers. This is the physical, because it was the physical and data link layer. Which layer of the TCP/IP model handles the functionality of the OSI network layer? That's internet. Network was internet. Okay. What kind of protocol is TCP? TCP is connection based. Let me check the chat. It's 2 a.m. in the UK, and so stay up to check out. Hey, Jason, I appreciate it, man. Get some rest, though. Don't burn yourself out. SYN is short for synchronize. What is the second step of the three-way handshake? That is the SYNAC. I said SYNAC. And last but not least, acknowledgement is ACK. Okay. All right, so things were a bit shaky starting out, but I think we're back on track. Okay. At this stage, hopefully all of the theory made sense and you now understand the basic models behind computer networking. For the rest of the room, we're going to be taking a look at some of the command line networking tools that can be used in practical application. Most of these tools do work on other operating systems, but for the sake of simplicity, I'm going to assume you're running Linux for the rest of this room. The first tool we're going to look at is ping. Ping is used when we want to test whether a connection to a remote resource is possible. Usually this will be a website on the internet, but it could also be for a computer on your home network if you want to check if it's configured correctly. Ping works using the ICMP protocol, which is one of the slightly less known TCP/IP protocols that were mentioned earlier. ICMP protocol works on the network layer of the OSI model, and thus the internet layer of the TCP/IP model. The basic syntax for ping is ping target. In this example, we're going to ping whether a network connection to Google is possible. So they ping Google, and they got back the 56, or they got the 84 bytes of data. Notice that the ping command actually returned the IP address for the Google server that it connected to rather than the URL that was requested. This is a handy secondary application for ping, as it can be used to determine the IP address of a server hosting a website. One of the big advantages of ping is that it's pretty much ubiquitous to any network-enabled device. All operating systems support it out of the box, and even most embedded devices can use ping. Have a go at the questions. Any questions about syntax can be answered on the man page for ping. Oh, I guess I have to start the attack box. Well, let's see. All right. What command would you use to ping the bbc.co.uk? So that's ping bbc.co.uk. Ping muirlandoracle.co.uk. All right, so I'm not going to do that. While I'm waiting for my machine to come up, I'll just go ping muirland oracle.co.uk. co.uk. It gave it to me in IPv6. Why did you give it to me in IPv6? I don't want it in IPv6. There we go. So for those who are looking at it on Windows, I did it originally and it gave me the IPv6, and then if you do -4, it'll do it in IPv4. So IPv4 gave me the IP address of 217.160.0.1, not 125, 152. Okay, what switch lets you change the interval of sent ping requests? I already know that. That would be -C. What? Let you change the interval of sent ping requests. Here you go. Come on, bring up my terminal, please. Man, ping, actually. -4, -B. Stop count after stop after sending count. What switch lets you change the interval of sent ping requests? Let me close this. It's dash. Okay. The interval of sent ping requests. Okay. All right, cool. What switch would allow you to restrict requests to IPv4? So I just said that. That was -4. What switch would give you a more verbose output? That'd be -V. All right, so we are done with ping. Now let's look at traceroute. So we're gonna hit Q to quit. Let's see. There. Let's say traceroute. Let's say -H. There's no. Is there no help page for traceroute? No. Okay. Oh, because I spelled it wrong. That would help. Oh, traceroute's not installed on here. Interesting. Okay, logical follow-up to the ping command is traceroute. Traceroute can be used to map the path you request takes. As the path your request takes as it heads to the target. The internet is made up of many different servers and endpoints, all networked up to each other. This means that in order to get to the content you actually want, you first need to go through a bunch of other servers. Traceroute allows you to see each of these connections. It allows you to see every intermediate step between your computer and the resource that you requested. The basic syntax would be traceroute. By default, the Windows traceroute utility is tracert. Operates the same ICMP over utilizing the Unix equivalent, operates over UDP, which can be altered with switches on both instances. As you can see, okay. Use traceroute on tryhackme.com. Can you see the path? Okay, but traceroute isn't working, right? So traceroute 6 works. I don't know. Let's see. Network is unreachable. All right, let's just for the sake of Okay, whatever. What switch would you use to specify an interface when using traceroute? So I guess since we have to use this one, let's say man traceroute 6. Okay, specify an interface. Why is it? Okay, you're not. So that would be -I to specify the interface. All right, what switch would you use if you wanted to use TCP SYN request when tracing the route? That looks like it would be GUI is overrated. Check the hops. Okay. All right. So let me see. D max probes, source, wait time, destination size. You want to use TCP SYN requests. Can you install? Let me see something. Cause I don't want to install, but let's see if it'll let me anyway. Oh, okay, so it does let you do it. Cool. I want to say the TCP SYN would be -T. But let's see. Man. Really? Okay. Yep, -T or --TCP. So -T. Which layer of the TCP IP model will traceroute run on default in Windows? TCP IP model, that would be networking or internet, right? Because the networking model is the internet model, right? Okay, cool. All right. Back on track. Let's see what this says here. I love the command line. I'm building my command line skills daily. No, you got to definitely know how to navigate, especially with Linux machines on the command line. It's a lot faster, too. Domain names. The unsung saviors of the internet. Can you imagine how it would feel to remember the IP addresses of every website? Horrible thought. Unfortunately, we've got domains. You know what I compare the DNS system to? I mean, it's true. Trying to remember every IP address would suck, but again, showing my age, back in the day, we had to memorize phone books. Right? We had to memorize phone numbers, or you walked around with like your little black book or whatever, your little phone book that you have, and you had to memorize numbers. And now you don't have numbers or anything like that you need to memorize. You have pictures or names or whatever, and that's essentially like what DNS is doing right now. DNS is translating the IP address name, or IP address to the name. So yeah, that's basically what the how I compare it with, like when I was talking to my kids the other day about it. My wife and I, we used to talk about how we had to actually remember the numbers, and then when we got cell phones, it was like, oh, okay, cool, we could just put the name in and program it. but that's essentially the same thing. All right, so where are we? We'll talk a little bit more about this, how it works in the next class, but for now, it would suffice to know that the domain translates to an IP address, so we don't need to remember it. You can type try-hack-me rather than a try-hack-me IP address. Domains are leased out by companies called domain registrars. If you want a domain, you go and register with the registrar and then lease the domain for a certain length of time. Enter Whois. Whois essentially allows you to query who a domain name is registered to. In Europe, personal details are redacted. However, elsewhere you can potentially get a great deal of information from Whois data. There's a web version of the Whois tool if you're particularly adverse to the command line. Either way, let's get started. You may need to install Whois before. So let's clear this out and then let's see if Whois is not there. So let's app install Whois. And like they said, you could also just bring up the Whois information here as well. So you can just go I am not a robot. That's a crosswalk. Oh, that's a crosswalk. Traffic lights. Oh, come on. All right, so you have this here, which is essentially the same thing as minimize that, as what we just installed. So we could just do it on both. All right, so perform a Whois on Facebook.com. So we'll just put it here, Facebook.com. Oops. Learn how to spell. So you have Facebook.com. Okay, and then we'll just put it also in here. Facebook.com. See if it gives us the same information. So we have the domain name, Facebook.com, domain ID, all that good stuff, right? And now let's so we have our name servers. (1601) Willow Road. Okay. We'll complete this. What is the registrant postal code for Facebook? 94025. Postal code 94025. When was the Facebook domain first registered? First registered, looks like 3/29/1997. So 03/29/1997. Oh, sorry, you have to do / registered on 3/29/1997. Okay. So it says that's wrong. Okay, so let's look through here real quick. Update creation date, it says 4/22/2004. But that's the creation date. When was it registered? (4/22). That's the expiration date. That's the updated date. That's the creation date of the, okay. But that's not right. Is it? Okay. All right. So yeah, there we go. So the problem was it wasn't that the date was wrong because the date is clearly right, 1997 329. However, um, it's a regional or a geographic thing. So I guess over there it's day, month, year, where over in the U.S. it's month, day, year. All right, so let's move on. We're gonna do Microsoft.com now. So we're gonna hit clear, tab up, and then we're gonna say Microsoft.com. All right, and then same thing here. We're gonna put Microsoft.com. All right, now, what city is the registrant based in? Redmond. What is the name of the golf course that is near the registrant address for Microsoft.com? So, okay, so the registrant address of Microsoft.com is, no, that's the administrative contact, right? Registrant contact information. Now, same thing, One Microsoft Way. So we're going to hit copy. We're going to go ahead and we're going to look. We'll say golf course near One Microsoft Way. Brings up the best 10. Get out of here. All right, so now we're looking for so Bellevue right now is 1.1 miles. That's 2.6, 1.4, 1.2, 1.1 is the Golfing Academy. Not for nothing, a lot of these golfing courses, okay, aren't getting great reviews. All right, so we'll say Bellevue Golf Course. Bellevue Golf Course. All right, what is the registered tech email for Microsoft.com? The registered tech email for Microsoft.com. So that's the admin. Technical, here we go, technical contact information. It looks like the same thing. Registered tech email. They're all saying admin at domains .microsoft. So let's see, admin at domains .microsoft.com. that's wrong. Okay. Let's see what you tell us. Do you tell us something different? Ah, tech email. There it goes, right there. See, that's why you have to check multiple sources. So, MS NHST at Microsoft.com. So if you saw that, and let's see, just to make sure I just didn't overlook it. When you looked here, nope, it wasn't here. So when you looked here, that was the technical information. So that information said the technical email address was the same as the other ones, which was admin.domain at Microsoft. But when you brought it up here in the command line, here's the admin email, so that's true. But when you looked at it, the registrant email, so the registrant email and the admin email were the same. But then when you found the registry tech ID, you scroll down to the tech email, you see it's MSN HST at Microsoft.com. So always check multiple sources. All right, so now we're going to look at Dig, which is another domain DNS tool. So we talked about domains in the previous test. Now let's talk about how they work. Ever wondered how URL gets converted into an IP address that your computer can understand? The answer is a TCP protocol called DNS, or domain name system. At the most basic level, DNS allows us to ask a special server to give us the IP address of a website we're trying to access. For example, if we made a request to google.com, our computer would first send a request to the special DNS server from which your computer already knows how to find. The server would then go looking for the IP address for google.com and then send it back to us. The one computer could then send a request to our computer could then send a request to the IP of the Google server. So remember, this is where I just had trouble. Due to the time difference, I normally miss a live stream. Stayed up today to show some love. Got to drop off now, but respect as always from London. Jason, I appreciate you, spending some time and chopping it up, man. I definitely appreciate the support. Get some rest, man. Get some rest and live to fight another day. Ah, okay. So I was. Taggart, thank you for following. I appreciate you. I appreciate the support. All right, cool. Where are we now? Okay, you make a request. So, using the example I was using before with the phone book, like I said, back in the day, you had to write down the phone numbers. You had to remember your phone numbers, and that was the only way you could send it. And then once people started getting cell phones, and technology advanced, you were able to program numbers into phones. But Taggart, thank you. Thank you for the raid. Nah, Chad, yeah. So the follow is Mega Man Proto Man from Mega Man 3. Yep. And then the raid was when you beat the stage in Contra. GoPro Slow-Yo, what's going on? No place like home. Yeah, so okay, so like I said, so that's what you do with DNS. It's basically memorizing the IP addresses to the names. So All right, where are we? Okay, so you make up a request. You make a request to the website. First thing your computer does is check a local cache, see if it's already got the IP address stored for the website. If it does, great. If not, it goes to the next stage of the process. Assuming the address hasn't already been found, your computer will then send a request to what's known as a recursive DNS server. These will all automatically be known to the router on your network. Many internet service providers, ISPs, maintain their own recursive servers, but companies such as Google and OpenDNS also control recursive servers. This is how your computer automatically knows where to send the request for information. Details for a recursive DNS server are stored in your router. This server will also maintain a cache of results for popular domains. However, if the website you've requested isn't stored in the cache, the recursive server will pass the request to the root name server. There are precisely 13 root names in the DNS servers in the world. The root name servers essentially keep track of the DNS servers in the next level domain, next level down, choosing an appropriate one to redirect your request to. These lower level servers are called top level domain servers, or TLDs. I was lurking until Mega Man. He's dual streaming, by the way, also on YouTube. Yeah, I'm on you. Yep, I'm doing both. I'm on YouTube and Twitch right now. Nope. Why is it not working? Oh, that sucks. Nope, still not working. All right, cool. Top level domain servers are split up into extensions. So, for example, if you were searching for tryhackme.com, your request would be redirected to a TLD server that handled the .com domain. If you were searching for bbc.co.uk, your request would be directed to a TLD server that handles .co.uk domains. As with root name servers, TLD servers keep track of the next level domain, the next level down. Authoritative name servers. Authoritative name servers. When a TLD server receives your request for information, the server passes it down to the appropriate authoritative name server. Authoritative name servers are used to store DNS records for domains directly. In other words, every domain in the world will have its DNS records stored on an authoritative name server somewhere or another. They are the source of information. When your request reaches the authoritative name server for the domain you're querying, it will send relevant information back to you, allowing your computer to connect. Okay, when you visit a website in your web browser, this happens automatically, but we can also do it manually with a tool called Dig. Like ping and traceroute, Dig should be installed automatically. So let's just double check. So we'll say clear, and then we'll say Dig, and Dig is installed. So that's good. We don't have to install it. Dig allows us to manually query recursive DNS servers of our choice for information about domains. Okay, so right here they did dig google.com at, and then they did the IP address of the DNS server, so 1.1.1.1. This is a lot of information. We're currently most interested in the answer section for this room. However, taking time to learn the rest of this means is a very good idea. In summary, that information is telling us that we sent it one query and successfully, with no errors, received the one full answer, which, as expected, contains the IP address of the domain name that we queried. Another interesting piece of information that Dig gives us is the time to live, or TTL, of the query DNS record. As mentioned previously, when your computer queries a domain, it stores the results in a local cache. The time to live of the record tells your computer when to stop, considering the record is being valid, i.e. when it should request the data again rather than relying on a cache copy. Time to live can be found on the second column of the answer section. Okay, so let's just get to the questions. What is DNS short for? We're going to say domain name service. System, sorry, not service. Alright, cool. What is the first type of DNS server your computer will query when you search for a domain? That was the recursive. What type of DNS server contains records specific to domain extensions? That was top level. That was a top level domain. Stop it. Thank you. Where's the very first place your computer would look for the IP address of a domain? That would be that was the, they said no, it wasn't the router. It was the local cache, right? Google runs two public DNS servers, or one of them can be queried IP 8888. What is the IP address of the other one? The other one wasn't. I mean, I know that answer, but I'm gonna say 8.8.4.4. If a DNS query has a time to live of 24 hours, what number would the dig query show? Let's Google it. Or is it TTL 24 hours dig? Is 20 Calvin, you said 2400? Based on the little hint, it looks like we might be missing a number. Time to live are in seconds, so 60, 24, 60. Okay. Okay. Oh, you can't see what I just did. All right. So, GoPro Slowyo says time to live is in seconds. So that would be 60 times 24 times 60. So 86,400. So 60 minutes an hour times 24 times 60 seconds. Okay. So 86,400. All right. Thank you, sir. 60 seconds in a minute, 60 minutes in a day, 24 hours. Yep. No, 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day. I think I read that wrong. Okay. Okay, further reading. Cisco self-study guide. All right, well, we are done, and we will share to Twitter. Let's get out of there. We'll just go. Introductory networking, intro to networking, successful user ping, phrase route, encapsulation. Let's get rid of these. Okay, boom. Yeah, whatever. All right, cool. So, yay. Oh, wait. Oh, that's what I should have done. Let me see if I can do it down from here. That sucks. That sucks. That sucks. That sucks. There we go. Okay, that looks like there is a lot going on in that question there. So I need to switch real quick. See what you're saying. I'm in college and got to choose a specialization soon. Systems and networking, full stack, or all right. Okay, hold on. I'm in college and got to choose a specialization soon. Systems and networking, full stack, or dev management. I'm very interested in networking, security, cloud, DevOps, and I like programming as well. I'm thinking of going the systems and network specialization, but the programming there is quite less in comparison to the full stack. I do want to apply programming to the subjects mentioned above, and none of those subjects get covered in full stack, and I'm not very interested in hardware. What do you think? Whew. Okay. Well, first, let's do this. All right. So you guys can see the chat. Um. So you said you enjoy. DevOps. I like programming as well. I'm thinking of going to systems network specialization, but the programming is quite less compared to full stack. I want to do programming, subjects mentioned. But you, okay, so you're interested in networking, security, cloud, DevOps, and I like programming as well. Um, I mean, I would, yeah, you could probably do, yeah, GoPro Slowyo says DevOps, SRE, basically full stack. Yeah, I would say you can go the DevOps route. Um, and I think for you for that would help with all the stuff because I mean that's in application security. So with application security, you would be dealing with the same thing: networking, security, cloud. You would deal with all of that. So yeah, I would probably say I would do the yeah. I'd probably look into doing the DevOps stuff. So that would probably be more of the probably the dev management. And then like I said, there's other in your you said automation tools. So yeah, I mean I would definitely look into that. Like networking isn't or the development and stuff like that isn't my strong suit or program isn't my strong suit, but I would definitely look more into the DevOps side of things, especially gearing towards more of like the security and cloud stuff. All right, so let's see what we got here. Kalila said, "Oh, that's my favorite fanfare, Final Fantasy." Oh yeah, I love Final Fantasy. I just need to have time to play it. I still haven't really gotten started on 15, and it's just sitting there because I refuse to trade it in or do anything with it until I actually play it. Like I have a whole list of games that are just like waiting to get played. It's just on my list. All right, so we need to close off our. We need to close out our stuff. Let's close our tabs. Shut down the attack box. I said shut it down. There we go. All right, where are we at? Me either. I'm gonna start sometime this year. I'm actually gonna start. I want to start once we once I figure out everything that I'm doing next, like InfoSec Unplugged is solid on Thursdays. So once I figure out flesh out the streaming schedule and kind of get everybody in the household acclimated to it, I really want to do gaming on like Fridays and Saturdays. And I want to do something like a gaming with friends on Fridays and Saturdays. And I'm thinking, like, I got Watch Dogs. I have Watch Dogs 3 that I haven't even played yet. I have Final Fantasy. I have like Gears of War. So I'm an Xbox head, um, and I'm waiting to get a PS5. I'll probably get both of them, but I'm just waiting. I'm not gonna chase it down right now. But yeah, I'm trying to get back to some type of form of normal. Once I set some of these goals, I'm gonna do this. Do you have an email for the public? Calvin, you can actually just email me at my blog, djax at alphacybersecurity.tech. Let me put that in the chat. That's my blog email address. So you can hit me up there. I mean, actually, you can go check out the blog too. While you're there and subscribe. Let's see here. What should we do next? Should we go into? Oh, we did. All right, I did Nmap already. I don't think I want to do Nmap again. Oh, I couldn't really do it again anyway because the answers were already there. So, yeah, I already did Nmap. So, where are we? Where are we on time? All right, let's see. Invite. Thanks. I do a ton of programming, reading other people's code, writing automation, debugging from TCP dumps all the way to application level. So full stack too. All while incorporating security. So yeah. Oh, GoPro Slow, yeah, like you're the truth. You the real deal. All right, so what time is it? How? It's almost 10 o'clock. I gotta get up in the morning with my daughter. So let's see. What's this room? Kiki, you and JB are are going tomorrow, right? Y'all are doing y'all are doing a stream. If you're still here, I thought I saw that on Twitter. So, if you guys don't know, Kalila Scott over here is also known as Key underscore twice on Twitter, and she runs the Tech Tech Chicks. So it's a really cool group. She's working with women to kind of get into cybersecurity, and she partnered up with another friend of ours, John Breth, aka J Bizzle 703 on Twitter, from Cyber Insight, and I believe they're doing a stream tomorrow. Yep, they're doing a stream on Wireshark. So I think you guys are going live at 6, right? Yep, 6 p.m. See, I be paying attention. So so y'all go check them out tomorrow at 6. Um, I'll probably stream earlier in the day, and then I'm gonna get off, or I'm gonna raid them. No, I can't raid them because they're on YouTube. I'm gonna get off so I could check out what they're doing on YouTube, and then I'll probably go on after that. But um, depending on how the day goes. But if that doesn't work out, you can also make sure you check me out on Thursday because InfoSec Unplugged will be back on Thursday. This week's guest will be Professor Black Ops, who is another content creator that focuses on cybersecurity, and he's on YouTube. So he's also an adjunct professor. So we're going to be talking a whole bunch of stuff that's cybersecurity, STIGs, and education related. I think that's gonna be a great show to come back. And then, like I said, just every Thursday from here on out, at least so far, I'll be back with InfoSec Unplugged. I don't know if you guys noticed, but like I said, I got the new little logo up here. So shout out to my cousin Chaz Underwood. Check him out on Facebook if you guys have Facebook. I know a lot of people cringe when I say Facebook. Mr. Underwood Designs, but go check him out. And also, if y'all are on Facebook, I need y'all to do me a solid. I need y'all to do me a favor. Actually, I don't even know if it's still up, and I should have did that yesterday, but I wasn't streaming yesterday. So my lovely wife, who I'm sure you guys have heard me talk about before, is a custom cake baker and create like dessert creator or creator extraordinaire, or whatever the hell you want to call her. But she participated in an international cake competition, and she actually made the cut. It was her very first competition. They wanted to, they asked her to incorporate something with the Four Seasons, and she created this design. Just kind of trying to find it. Here we go. And move it over here. And if you actually look, you'll see that she incorporated all four seasons. So down here you see winter. Back in the back you see that's the summer with the beach and the sand. Over here you see the springtime with the picnic, and then you see the fall with the fall leaves and everything, and then you see the trees with the different flowers of the different seasons. And the crazy thing about that is this is all edible. All of this is edible. So from the mountain, from the little hilltops over here, the ground, the sand, the snowballs, even the water, that's all edible. So, oh, sorry, my bad. Still getting used to this new setup. So, like I said, all of this is edible. So the water, the logs in the water. Let's see if I can. All right. The flowers, the tree. The leaves, pumpkins, the water, all of that is edible. The hills. So like I said, so right now she's in the running. I don't know if voting ended, but if you are on Facebook, let's see if this is the right link. If you are on Facebook, is that frosting? No, it's actually fondant. So it's fondant, and then there's like Rice Krispie treats and cake and all kinds of stuff going on. Like I don't try to pretend to know everything that goes on with her, just like how she doesn't pretend to know cybersecurity stuff. But is that frosting as snow? No, that's fondant. That's fondant. So that's all fondant. The sand is like I believe the sand was like graham crackers. So if you guys are on Facebook, please just check out that link and give it a like, because that's how they're actually tallying their votes based on the reactions they're getting on Facebook. So with that being said, it's now 10 o'clock. I need to get myself situated for the next day. But like I said, please check out that stuff on Facebook. Please like, follow, subscribe. Check me out there. If you guys, again, hold on, let me see. So please remember to like, follow, and subscribe to the channel. And also, if you like what I'm doing, please, you could also buy me a coffee. I appreciate all the support. I will be back, like I said, on Thursday. I have Professor Black Ops. Actually, I have I don't want to announce next week's guest just yet, but I got a lot of stuff lined up, and I actually have a big one lined up on the 20th of May as well. So make sure you stay tuned for that one too. So if you guys don't already, like I said, like, follow, subscribe, hit the bell for notifications. This way you guys know. Thanks. Shout out to everybody who's here. So shout out to Chad. Shout out to GoPro Solio. Shout out to NXX. Shout out to Kalila. Shout out to Calvin. Calvin, like I said, I'm gonna check out that email. Shout out to everybody that's here and continues to support me. I'm going to figure out what I'm going to do and get some rest, and I will talk to you guys tomorrow, hopefully, Lord willing. So take it easy. Everyone have a great night for Twitch Raid. Oh yeah, hold on. Let me see. I'm gonna see if I can do that. I'm trying to do that now. I've been trying. Okay, there we go. Who's on right now? Oh, we got Black Hacker, and then okay, you know what? I'm gonna support. So let's see. Okay, let's see if we do that. If we raid, did that work? I'm still trying to figure out this stuff, so let me see if I can get this thing to work. So according to the app with the Streamlabs stuff, gotta hit the raid button after the countdown. Yeah, according to this, well, see, I'm trying to use my this Stream Deck. It said you're supposed to. Yeah, it says you're supposed to just hold the button down, but it doesn't seem to work.
In this secret.
But y'all take it easy. Go check them out over there.
Wow.
And I'll see y'all later.
What's good, DJ? Thank you for the raid.